Hi class, today's lesson is lesson 7-4 in our unit on proportions. Today's purpose is to use proportions to find missing measures in similar figures. We're going to look at a little bit of geometry over the next couple lessons and deal with proportions in the context of geometry. Here's our first vocabulary terms: corresponding sides and angles. Corresponding sides and angles. Corresponding sides and angles are matching sides and angles of two or more polygons. All right. Now, what I want you to go ahead and do is I do want you to go ahead and copy this illustration, these two rectangles. I want you to copy down their measurements in terms of angle measurements as well as their length and width. Matching sides and angles of two or more polygons are called corresponding sides and angles. For example, here we're matching the 3 centimeter side of this rectangle to this 9 centimeter side, and we term those as corresponding sides. Now, the two arrows here are pointing toward 90-degree angles in two similar rectangles, and we call those corresponding angles. Next vocabulary term is similar figures. All right, similar figures. Two figures are similar if the measures of the corresponding angles are equal. That means if we take a look at matching angles, that they are identical. They are the same measure. And ratios of the lengths of the corresponding sides are proportional. Let's take a look at what I mean. Here we have the same illustration as before. Here the angles, corresponding angles are equal, 90 degrees and 90 degrees. And here we've got the corresponding sides that we are going to take a look at to see if they are proportional. Let me go ahead and look at ABWX. AB and WX. AB is 2 centimeters. WX is 6 centimeters. It should be equal to the proportion of the other two corresponding sides, which is AD, 3 centimeters, to WZ, 9 centimeters. Are these the two ratios that are proportional? Are these two ratios proportional? Well, we can say that they are. 2 to 6 is as 3 to 9. How do we figure that out? Cross multiply. 2 times 9 is 18. 6 times 3 is 18. Therefore, we know that these are similar figures. These are similar figures. Next, let's take a look at first example. It says the two triangles are similar, so we know that they have same corresponding sides. That corresponds to that. This side corresponds to this side. This base corresponds to this base. And that the angles are themselves corresponding. This angle equivalent to that angle, etc., etc. Now it says find the missing length x in the measure of angle A. So what I do first is I look at where is the missing side right here. So I know it's going to be 6 centimeters to x centimeters. 6 to x. Now I'm going to take one of the other sides as well. In this case, I'm going to go ahead and take 8 to 12 because they should be corresponding as well. If they're similar, and they does tell us that these two triangles are similar, so these two triangles are also proportional. When I cross multiply, I have 8x over here. 6 times 12 is 72. Put an equal sign right there. Divide both sides by 8. the x drops down. 72 divided by 8 is 9. So the measurement x is 9 centimeters. Now the other part of this is not only do they want us to get the length, but they want us to give the measure of angle A. Angle A is right up here. What is the angle that is corresponding to angle A? Well, it would be this one. And so angle A is equivalent to angle B. Therefore, angle A must equal 37 degrees because angle B is 37. That was pretty easy. Next we have a word problem. It says, children at the ice cream stand was painted by American artist William H. Johnson. This reduction is similar to the actual painting. The height of the actual painting is 32 centimeters to the nearest centimeter, which is the width of the actual painting. Now, as we look at this is a rectangle. And if we were to draw something that we have to imagine that this is the actual size. It says the height of the actual painting is 32 centimeters. So the height of the actual painting is 32 as opposed to 5 1/10 centimeter. Now we've got to figure out what is the width. So we go ahead and set up the proportion. We know 32 is to 5.1. Oops, let me go ahead and undo that. 32 is to 5 1/10. 32, these two sides, the height. So we started with this particular one. We're going to go ahead and go to the other side, and we're going to go ahead and look at this width first. So we start on the top figure here, applies to this rectangle rather than this rectangle. So we go ahead and start with the width of this rectangle. So 32 is to 5.1 as W is to 6. Now what we're going to go ahead and do is we're going to cross multiply. It's 32 times 6 equals 5.1 times W. When we do this, we're going to go ahead and figure, oh, it's 32 times 6. I'm going to put that up here in the corner. 32 times 6 is 12. 6 times 3 is 18, 19, 192. So 192 equals 5.1 W. Now with that, I need to go ahead and divide both sides by 5.1 in order to isolate that variable. What I come out with is the 5.1s knock each other out. The W drops down, and now we have 192 divided by 5.1. So I'm going to go ahead and figure that out right down here. Now I'm going to move that decimal point over 1. That means I've got to move this decimal point over 1, which now means my new division problem is 51 into 1,920, or 1,920 divided by 51. When I go over here, I see that 51 does not go into 1, it does not go into 19, but it goes into 192, 3, almost 4 times. So 3 times 51, 3 times 1 is 3, 3 times 5 is 15. Now I go ahead and subtract. 12 subtract 3 is 9. And I borrowed there. 8 subtract 5 is 3. I bring down the 0. How many 51s in 390? And I'm going to say, I'll say 4, 5. I'll say 5 at this point. Actually 6, isn't it? 6 or 7. So let me go ahead and go up to 7. 7 times 1 is 7. 7 times 5 is 35. What I'm left with here, now I've got to put the decimal down here. What I'm left with is 90 subtract 390 subtract 357. That's a 3. 330. How many 51s into 330? I know that's going to be about 6. 6 times 51 is going to be 6. 6 times 30. Now, I don't have to go any further because it says go to the nearest centimeter. So my width is going to be 37.6 centimeters at this point. To the nearest centimeter, that would be 38. So my answer is 38 centimeters is equivalent, is about the width of the actual painting. There we go. Here are your problems for tomorrow. It says the two triangles are similar. Find the missing length x and the measure angle g. Remember, you're looking for two things here for your complete the problem, the missing length and the measure of angle g. And then you've got a word problem, similar to the one that I just completed. All right, we'll see you in class.